here we are gonna see a numerical on beta function. We are gonna solve it by the definition and the properties of beta and gamma. So let's start with it. So here I have integration from minus pi to pi sine square x cos raised to 4x dx. Now to get the value of this integration, we have the definition of beta function. So first of all, I'll show you the definition. So here on your screen you can see that at point number 4 we have a definition of beta which has the sine and cos term. So if I want to apply this definition of beta function, then I must bring the limit from 0 to pi by 2. Now in our case it is from minus pi to pi. So we have to bring it from 0 to pi upon 2. So for that we have to use either the method of substitution or some properties of a definite integration. Now guys, if we want to use the method of substitution, then you can see here that already we have angle as x, and as per the definition we want angle as x only or theta. So we cannot use the method of substitution over here to get the value. So here we will use the properties of definite integral. Now guys, if you observe carefully, then here limit is from minus pi to pi. So here we can apply the property of even and odd function. So for that I'll consider this given integral as I. So here I'll say let I equal to integration from minus pi to pi sine square x cos raised to 4x dx. Now what is the property of even and odd function? So here let me show you that if integration is from minus a to a f of x dx, then its value can be given as 2 times integration 0 to a f of x dx if that function f of x is even, or we say that the value of this integration is 0 if that function f of x is odd. Now guys, here we just have to check this function f of x. If it is even, then result 1 we can write down for this integral. Now if you see the f of x, it is sine square x cos raised to 4x. Now how to check whether it is even or odd? So for even we generally check the result for f of minus x, and if value of f of minus x is equal to f of x, then we say it is even function. So let's check over here. So f of minus x would be sine square of minus x into cos raised to 4 minus x. So this will become sine of minus theta, that is minus sine theta, but due to this square it will be positive sine square x, and cos of minus theta is cos theta, so that is cos raised to 4x as it is. So guys, it means we are getting the original function f of x back. Hence we can say that this given function is even function, and therefore we'll write down this result, which is 2 times 0 to a. So in our case a is pi, so 2 times 0 to pi sine square x cos raised to 4x dx. So I'll write it down on next line. Now guys, here we got the integration from 0 to pi, but if I want to apply the definition of beta function, then the limit must be from 0 to pi by 2. So now question is how to make it from 0 to pi to 0 to pi by 2. So for this we will use one more property of definite integration. So what is the property? So here I'll write the property for you. So the property says that integration 0 to 2a f of x dx can be written as integration 0 to a f of x dx plus integration 0 to a f of 2a minus x dx. So guys, if we'll apply this property, then here 0 to 2a is 0 to pi, means the value of 2a is pi. hence the value of a will be pi upon 2. So here we can get 0 to pi upon 2, 0 to pi upon 2. So here I'll write it down that I is equal to 2 times in the bracket 0 to pi upon 2 sine square x cos raised to 4x dx plus again integration from 0 to pi by 2. Now here we have to find out f of 2a minus x. So here value of 2a is pi. So here I'll write it down sine square pi minus x into cos raised to 4 pi minus x dx. Now guys, it is 2 as it is. Here we'll say integration 0 to pi by 2 sine square x cos raised to 4x dx as it is. Now here plus integration from 0 to pi upon 2. What is the value of sine pi minus theta? So it is sine theta, so this will be sine x, and due to square that will become sine square x. Similarly, cos pi minus x is minus cos x, but due to this power 4 that will become positive cos raised to 4x dx. So in short guys, we are getting the same integration 2 times. So I can say it is twice, and this 2 is already there, so 4 times this integration, so which is equal to 4 times integration from 0 to pi upon 2 sine square x cos raised to 4x dx. And now it is matching with the definition of beta function. So let's see the definition once again. So as per the definition, the power of sine is p, and for cos it is q, and here we get p plus 1 by 2, q plus 1 by 2, 1 by 2 outside. Now here the power of sine is 2, so p is 2 and q is 4. So this will be 2 plus 1 by 2, that is 3 upon 2, and 4 plus 1 by 2, that is 5 upon 2. So here I'll say it is equal to 4 into 1 by 2 beta of 3 by 2 comma 5 by 2. Now we'll solve this beta function by using the relationship between beta and gamma. So here we will get 2, 1s are 2 and 2 2s are 4. Next, this is gamma 3 by 2, gamma 5 upon 2 whole upon gamma 3 upon 2 plus 5 upon 2. Now guys, let's solve this. So to solve this gamma 3 upon 2, we'll use the property which is gamma n is equal to n minus 1 gamma n minus 1. So here 3 upon 2 is my n. So 3 upon 2 minus 1, that is 1 upon 2 gamma 1 upon 2. And the value of this gamma 1 upon 2, we know it is root pi. So we will stop here, will not go further. Next, for gamma 5 upon 2, I'll once again apply this property. So 5 upon 2 minus 1, that is 3 upon 2 into gamma 3 upon 2. And the value of gamma 3 upon 2 just now we got is 1 upon 2 gamma 1 upon 2. Now in the denominator, this is 8 upon 2, that is 4. So gamma 4, and we know that gamma n is n minus 1 factorial. So gamma 4 will be 3 factorial. Now guys, let's cancel the things. So 2 and 2 will be cancelled. Here next I'll say it is equal to 3 by 4, 2 2s are 4. Then gamma half is root pi into root pi, that is pi, by this is 3 factorial, that is 6. And here if we'll solve this, then we will get pi by 8. So guys, the value of integration is pi by 8. So here we have solved this given integral by using the definition of beta function and the properties of beta and gamma. And if you like this video, then do subscribe, do log in to ekida.com today itself, and you can enjoy all the concepts and all the numericals of engineering mathematics at one place. Thank you very much.